So what we have is a quadratic equation that we are supposed to solve by completing the square. Completing the square only works if the leading coefficient is 1. Here the leading coefficient is -3, so we need to get rid of it. At this point, we are allowed to divide both sides by -3, but I'm just going to do what is always allowed, which is factoring out the -3. So if we factor out -3, what do we get? -3 times 1x squared will give us -3x squared. We have a plus here, we have a minus. That means that the multiplication will only work if this is a minus 8x, right? Because -3 times -8x will be plus 24x. And here, if we want a negative sign, we have to use a plus here, so the multiplication backwards work. Whenever you factor out the negative numbers, slow down, because people make errors there, and not only you lose points, but the numbers stop cooperating. You make a tiny error and the problem becomes so much harder. So slow down and make sure that you didn't miss a sign when factoring out a negative number. All right, we're going to drag along the -3, and inside the parentheses, we're just going to complete the square. So half of the linear coefficient is -4. So we go to the margin and we work out the complete square, x minus 4 squared. So x minus 4 squared, when we FOIL out x minus 4 times x minus 4, is going to be x squared minus 4x, giving us minus 8x, plus 16. This complete square and our expression has the same first and second terms, which is why this is going to work. What we are missing, and the plus 12 is just waiting here. What we are missing is this 16 here. So this is called the smuggling step. Plus 16 minus 16. We just added 0, right? This is what we want. This is the payoff. Because we are not allowed to change the value of the expression. So we just added 0 in a strange way. And you might say they're canceling out each other, but they're not going to have the chance, because this first 3 is getting absorbed in the complete square. Right, this is the first time we used this line when we decided to smuggle in 16. The second time is when we convince ourselves that x squared minus 8x plus 16 can be rewritten as a complete square, x minus 4 squared. And then we just combine what's left. -16 and plus 12 combined to -4. And that's good news, because 4 is a square. This is going to be a line you're going to skip eventually. I just want to make sure your notes are thorough. So you're not going to need this line. The difference of squares theorem states that a square minus another square can always be factored into grab the things you squared, add and subtract for the conjugates, and multiply those two. So if a is x minus 4 and b is 2, we have x minus 4 plus 2, x minus 4 minus 2. We factor this via the difference of squares theorem. This is the moment we don't really need this big parenthesis anymore. So we have -3 times. Now we just combine like term. There is x minus 2 and x minus 6. We factored by completing the square. Now we're going to apply the zero product rule. -3 is never 0. X minus 2 is sometimes 0 when x is 2. And x minus 6 is also sometimes 0 when x is 6. So we think there are two solutions, 2 and 6. Okay, if we can, we should check. We're going to check with 2, and I'm going to leave checking with 6 to you. Don't mess with the first line because we go back there. So the left-hand side is -3 times. If x is 2, then x squared is 4, plus 24 times 2 minus 36. So we have -12 plus 48 minus 36. And if you combine the negative ones, you get -48. So we get 0. So our solution, x equals 2, works. When you check, you will find that x equals 6 will also work. Thank you for watching.